devices. Third one, corrosion and its control method. Fourth one, polymers and its composites and composite material. Fifth one, nanochemistry. So, 22CH101 is our subject code. Subject name is engineering chemistry. The engineering chemistry has been separated by the 5 main units. First one is the water and its treatment. Second one, electrochemistry and energy storage devices. Third one is energy storage. Third one is corrosion and its control methods. Fourth one, polymer and composites. Fifth one is the nanochemistry. These all should be applicable for your domain. If you want to make any one of the device, if you want to make any one of the prototype, you want to be applying for all this. What is the basic things to the your project? Okay, if you take the water, what is the main aim of the Chandrayaan missions? How many payloads are uploading that? How many payloads are there? Nearly 7 payloads. So, எதற்காக Chandrayaan mission land பண்ணாங்க? Water access பண்ணாங்க. So, they have to fit into the sensors. Which sensors have been using that? There is a nano sensor is using that. Okay. What is the how many purity of the water? What is the depth of the temperature in the surface of the moon? This all will be what is the find out using the sensors. Okay, the satellite which is made up of the composite materials. That is the golden color. What is the Vikram ladder is into it? Golden color satellite is there. That is made up of the composite material. Why we using the composite material? That is the highly thermal and what is the electrical resistance material. Okay, if we want to combine with any one of the project, we want to have it, must we have the certain basic things about that. Okay, now circuit develop பண்றது மட்டும் என்ன இருக்கு, sensors develop பண்றது மட்டும் என்ன இருக்கு அப்படினு வைக்க முடியாது. Because நம்ம ஒரு ப்ராஜெக்ட் எடுத்துட்டோம் அப்படினா அந்த ப்ராஜெக்ட்டுக்கு ஓவரால் டிசைன் கம்பைன் பண்றதுக்கு நமக்கு ஒரு டிவைஸ் கம்பைன் பண்றதுக்கு we want to be the basic knowledge of that based on your project. Okay va? So அப்ப அத பேஸ் பண்ணி நம்ம அங்க போய் லேர்ன் பண்ண முடியும். Basic things இங்கே தெரிஞ்சதுனா we have to apply our knowledge into that to resolve the problem. Okay, so that's why we have designed our syllabus based on the industrial 2. That is first one is water and its treatment. Second one is electrochemistry and energy storage devices. Third one is corrosion and its control methods. Fourth one is polymers and composites. Fifth one is what is that? Nanochemistry. First we are going to see about our first topic, water and its treatment. UNIT1. Fourth one, of the brackish water, that is called RO process. The next one, boiler troubles. There are four main boilers. When the water are feed into the boiler, it may be facing the four main troubles. Is the first one, scales, sludges, piping, and foaming. Last one is the treatment of water. Before we feed into the water, we have to treat the water. That is called internal treatment. After feeding into the water, that is called external treatment. So this both treatment we will be discussing this topic. Okay. First one, we are going to see about sources and impurities of water. Very fast.
Without impurity.
sulfate. So that all the minerals are called, whether it is cation or anion. What is cation? What is anion? Positively charged molecule is called cation. Negatively charged molecule is called anion. If I asking you, if you take magnesium, what is the anionic part? What is the cationic part? That they are CN-. Okay, that's enough. Okay, so whether it is organic or inorganic, whether it is cation or anion, it is not a matter. All the minerals are comes for the inorganic dissolved impurities. Okay, if the excess amount of iron is present in water, which color is used as the given at type? Excess amount of iron is present in your water. Which color shown? Reddish brown. Okay, reddish brown color is shown. If excess amount of chromium is present, yellow tinge is shown in your water. Okay, so that are all what is that? Inorganic dissolved impurities are present in it. Okay, next one C. Gaseous. Often see more stated like a CO2, H2S, sulfide gas, nitrogen gas. So that kind of gases we can't able to separate from the water. So that are the gaseous impurities, dissolved gaseous impurities. So what is dissolved impurities? Dissolved impurities is nothing but the impurities which cannot be easily separated. It is completely soluble. That kind of impurities is called dissolved impurities. Next one C. Suspended impurities. What is the meaning for suspended? It is partially soluble in water. If you take it in the office, taking the powder for that and mixing with the water, what we do? Partially soluble, remaining will settle down. That kind of impurities is called suspended impurities. The suspended impurities are also classified into two types. First one organic, second one inorganic. See some of the examples of suspended impurities. Iodide. It is not completely soluble in water. Whether it is kerosene or ginger oil or castor oil, okay, or diesel, petrol, it is not completely soluble in water. It is partially soluble in water and partially soluble on the surface. So that grease, so that are all the example of suspended impurities. So next one, inorganic. What is that? Clay, mud, sweet. So that are some of the examples of what is that? Changing the turbidity nature of the water. So it is partially soluble in water. So that is called suspended impurities. So what is the difference between dissolved impurities and suspended impurities? Dissolved impurities are
fully soluble.
completely soluble. Suspended impurities are
Partially soluble.
Okay, so next one, see, colloidal impurities. The particle size having 10 power minus 4 meter. The particle is called colloidal particle and the impurities is called colloidal impurities. Okay, next one, see, microorganisms, all the viruses, bacteria, funguses are present in the water. It should be changed the color into green. That kind of impurities is called microorganism impurities. So totally there are 4 main kinds of all the water quality parameters are measured by ppm. ppm means parts per million. That is called ppm. Okay. So there are various water quality parameters are available. There are chloride, sulfide, hardness, alkalinity, and fluoride, acidity. But in our syllabus we have discussed only about the 10 parameters. Okay, COD, hardness, alkalinity, pH, and DO. These are oxygen and color, rapidity, and also what is the odor, TDS, and BOD. These only 10 parameters are discussed in our syllabus. But apart from that, we have discussed the various what quality parameters is that chloride, fluoride, arsenic, sulfates. Okay, so our here only we have discussed only 10. Okay, so the World Health Organization determined the hardness level should not be exceed than 500 ppm, alkalinity level within less than 300 ppm, chloride level within less than 250 ppm. Okay, TDS amount within the level having the 350 ppm. Dissolved oxygen level must be 4 to 6 ppm. So that are all standards are fixed by the World Health Organization and Indian Research Medical Council. So these councils also classify into the three main classifications for the water quality parameters. First one is the chemical parameter, second one is the physical parameter, third one is the biological parameters. First one, chemical parameters. If excess amount of chemical properties are, what is that? Store that is called chemical parameters. If we can easily find out whether the changes are, whether the pollutants are present in the water in our land life, that is called physical parameter. If the water is polluted by the living organisms, that is called biological parameters. That are all for impurities means that is called pollutant. Okay, if excess of chemical pollutants are present, we can afford that is the chemical parameter. We can easily find out which kind of color, maybe changes or what difference in odor. We can easily find out the what is contaminated here. So that is called physical parameters. We easily sense into that. That is called physical parameters. Last one is biological parameters. If excess of living organism is there, whether it is bacteria or fungus or viruses, it may be turned the color of the water into the greenish. So that kind of parameter are measured by that. What is the biological parameters? Okay, first one we see about the color. What is the color? What is the color of the water? Colorless. It is the colorless liquid. There is no color for that. If already I told you, if the excess amount of iron is present, it is shown by the reddish brown color. If excess amount of bromine is present, it is looking like yellowish tinge. So we can easily what is identify if some of the pollutants are mixing there by our black light. That is called color parameter. The color parameter are measured by true color unit. The color parameter are measured by true color unit. The acceptable the permissible limit of the color parameter is 50 TCU. TCU means true color unit. So color parameter எதுல measure பண்ணுவாங்க? True color meter அப்படிங்கிற unit அப்படிங்கிற அந்த குவாண்டிட்டியை வச்சு மெஷர் பண்ணுவாங்க. ஓகேவா? acceptable limit எவ்வளவு? 50 TCU. Which of the instrument is used for that? Instrument note putting. Which of the instrument is used for to measure the color parameter? That is called tintometer. Tintometer. Tintometer is an instrument measuring the color parameter. Okay. So next one, we go into the turbidity. If excess amount of clay, mud, or inorganic suspended impurities are present in the water may be turbid in nature. The turbidity are removed by oxidation followed by precipitation. There are two main methods for removing the turbidity. First one, oxidation followed by precipitation. Okay, next one we discuss about odor. If the excess amount of dissolved gases are present in the water, that means what are the gases? CO2 or H2S or N2, that kind of gases are present in the water. It may be creating gases in odor. Okay, so that this is also separated by first one, what is the oxidation followed by precipitation. During the oxidation, all the ions from the H2S CO2 are settled down. We can one, TDS. TDS means total dissolved solid. TDS means total dissolved solid. Whether the solid is organic or inorganic or cation or anion, that all the content are combinedly we have tell about TDS. TDS means total dissolved solid. Okay, the total dissolved solid can be removed by see some of the total dissolved solid for the day-to-day using products. First write the drinks and write and second write the TDS. Okay, first here you go. Maybe this is what the TDS is. TDS is for the first one drinks in for it. Here we come the same drinks for this TDS.
Drinks.
Drinks is a TDS. First one Coca-Cola. First one Coca-Cola. Other TDS amount 2.5. 2.5 Coca-Cola. Here 2.5.
What is the unit for TDS, ma'am? Unit, ppm or the
ppm, all alkali ceramic solution in ppm. Second one, vinegar, 2.9 ppm. 2.9 ppm. Apple juice, 3.5 ppm. Define TDS. Define TDS. The total dissolved solids is the measure of the total dissolved solid is a measure of the dissolved combined content of inorganic dissolved combined content of inorganic, organic, molecular, ionized or microgranular suspended form. Microgranular, inorganic, organic, molecular, ionized, inorganic, organic, molecular, ionized, microgranular suspended form. The concentration of TDS are measured by ppm. The concentration of TDS are measured by ppm. The concentration of TDS are measured by ppm. Second, turbidity.
define termination.
Define by ppm. The concentration of TDS are measured by ppm. Yeah. Second one, turbidity. Turbidity is important to natural waters due to the presence of inorganic insoluble due to the presence of finely divided insoluble impurities. Due to the presence of finely divided insoluble impurities. Say some of the example: organic impurities, inorganic impurities. Inorganic impurities. Clay. organic impurities, fats, organic impurities, fats, greases, grease, fat, organic impurities का fat है, और grease, animals matter, that means excreted substances, animals matters, wasted vegetables, waste vegetables, are some of the examples of organic impurities. Turbidity can be removed by sedimentation. Turbidity can be removed by sedimentation, followed by coagulation and filtration. Turbidity can be removed by sedimentation, followed by sedimentation க்கு அப்புறம் என்ன செய்யணும்? coagulation. அதுக்கப்புறம் filtration என்னங்கறத மிஸ் ப்ராப்ளம் பண்ணுவோம். sedimentation என்ன, coagulation என்னங்கறத பார்ப்போம். sedimentation followed by coagulation and filtration. Turbidity are measured by photometer. Turbidity are measured by photometer. Expressed in pharmacy turbidity unit, FTU, this is the bracket FTU, pharmacy turbidity unit, expressed in photometer என்ன டிஸ்ப்ளே ஆகும், pharmacy turbidity unit டிஸ்ப்ளே ஆகும். அத நம்ம எப்படி கன்வர்ட் பண்ணிக்கணும், மீடியமா கன்வர்ட் பண்ணிக்கணும், அவ்வளவுதான். அந்த மீட்டர்ல என்ன மாதிரி டிஸ்ப்ளே ஆகும், நமக்கு வரது FTU வாட் டிஸ்ப்ளே, அதனா 10 - 4 10 - 6 அந்த சேஞ்சஸ் தான் வேற. photometer மூலமா நம்ம turbidity மெஷர் பண்ணுவோம். அந்த photometerல என்ன யூனிட் எக்ஸ்பிரஸ் பண்ணுவோம், அது என்ன டிஸ்ப்ளே ஆகும், FTU, pharmacy turbidity unit, pharmacy நிறைய யூனிட் வரும், pharmacy turbidity unit. Next one, discuss about COD and BOD. COD means chemical oxygen demand. Define COD and BOD. Define COD and BOD. Listen. COD means, I give the notes for it. First listen. COD means chemical oxygen demand and BOD means biological oxygen demand. If according to see any one of the plant or that, if the excess amount of chemicals are present in it, first undergo the chemicals into the oxidation process. So already we know that the water having the oxygen itself, that oxygen is called dissolved oxygen, that is called DO. Before we discuss about the COD and BOD, we want to know about the DO. DO means that is called dissolved oxygen. Okay, so oxygen and all the water should be inherent itself as a dissolved oxygen. Using this oxygen on applied chemicals are there. Okay, so the dissolved oxygen ppm must be 4 to 6 ppm. For a better water, it must be itself having the dissolved oxygen 4 to 6 ppm. If below the 4, that is impure water. Above the 6 also impure water. So the appreciable limit of DO present in the water within the limit is 4 to 6 ppm. Okay, if the excess amount of chemicals are present in the water, it may be undergo the oxidation. For oxidation process, we need the oxygen. The oxygen should be taken from the water. Water already is here, and the oxygen consume பண்ணி the oxidation process will be held. So the amount of oxygen required to break the molecules, that is called COD. So chemicals na oxidation நடக்கிறதுக்காக வாட்டர்ல இருக்கிற ஆக்சிஜனை எடுத்துட்டு அந்த மூலக்கூறை பிரேக் பண்றதுக்கு எங்க இருந்து ஆக்சிஜன் எடுத்துக்கும், வாட்டர்ல இருந்து ஆக்சிஜன் எடுத்து பிரேக் பண்ணும், ஆக்சிடேஷன் process நடக்கும். அந்த process பேர் என்ன சொல்லுவோம், COD. is COD. The chemical, if the excess of chemicals are present in the water, it undergoes the oxidation process. The oxygen consumed from the water, the amount of oxygen required to break the molecule, that process is called COD. ஒரு வாட்டர்ல நிறைய இந்த கெமிக்கல்ஸ் இருக்கு. Chemical pollutants are present in that. And the chemical pollutants are undergo the oxidation. So அந்த oxidation-க்கு என்ன தேவை? We need the oxygen. அந்த oxygen எங்க இருந்தா இருக்கும்? வாட்டர்ல இருக்கிற dissolved oxygen தான் கன்சியூம் பண்ணிக்க முடியும். அப்ப அந்த வாட்டர்ல இருக்கிற dissolved oxygen கன்சியூம் பண்ணி oxidation process நடக்கும். அப்ப வாட்டர் ஆட்டோமேட்டிக்கா என்ன ஆகும்? Dissolved oxygen level will be decline. 4 to 6 இருக்கணும்னு சொல்றோம். அது 4 to 6 விட என்ன ஆகும்? Should be decline. ஓகே, அப்ப என்ன நடக்கும்? அந்த ஆக்சிஜன் யூஸ் பண்ணி ஆக்சிடேஷன் process நடக்கும். அந்த chemicals எல்லாம் break பண்ணி என்ன decompose ஆகும். So அந்த process பேர் என்னன்னு சொல்றோம்? COD. The amount of oxygen required to break the molecules by oxidation process, that is called COD. Similarly, the amount of oxygen required to break the molecule by the oxidation process through microorganism, that is called BOD. Biological living organism அந்த வேலையை செய்யும். அது என்ன செய்யும்? கெமிக்கல்ஸ் எல்லாத்தையும் ஃபீட் பண்ணி அதை பிரேக் பண்ணி அந்த எக்ஸ்கிரியேஷன் அது கொண்டு போயிடும். ஓகே, டீகம்போஸ் பண்ணி கொண்டு போகும். ஆனா அந்த எக்ஸஸ் ஆஃப் லிவிங் ஆர்கானிசம் ஒரு வாட்டர்ல இருக்குன்னா அது ரெஸ்பிரேட் பண்றதுக்கு நீட் சம் ஆக்சிஜன். அப்ப அந்த ஆக்சிஜன் எங்க இருந்து எடுத்துக்கும்? வாட்டர்ல ஆக்சிஜன் டிசால்வ் ஆக்சிஜன் தான் எடுக்கும். அப்ப ஒரு பவுண்ட் ஆர் லேக்ல எக்ஸஸ் ஆஃப் மைக்ரோ ஆர்கானிசம் இருந்தாலுமே அந்த டிசால்வ் ஆக்சிஜன் லெவல் கம்மியாகும். அந்த கெமிக்கல் பொல்யூட்டனை பிரேக் பண்ற வேலையை கெமிக்கல்ஸ் வந்து ஆட்டோமேட்டிக்காக ஆக்சிஜன் ப்ராசஸ் மூலமா நடந்துச்சுன்னா தட் இஸ் கால்ட் COD. அந்த கெமிக்கல்ஸ் பிரேக் பண்ற வேலையை ஒரு மைக்ரோ ஆர்கானிசம் செஞ்சா தட் இஸ் கால்ட் BOD. BOD means biological oxygen demand. Define COD and BOD. Amount of oxygen. First one, COD. Amount of oxygen required to chemically break down the pollutants. Amount of oxygen required to chemically break down the pollutants called COD. Amount of oxygen required to chemically break down the pollutants called COD. Next one, BOD. Amount of oxygen required to do this biologically. Through microorganism called BOD. Through microorganism called BOD. See, next one, pH. So already we have discussed color, quality, odor, TDS, COD and BOD, and these are oxygen. The rest of it is alkalinity, hardness and pH. What is the pH of water?
7.
That is neutral. Above water,
Acids. Sorry, base.
base nature. Below water, acid. So the acceptable limit of drinking water is 7 to 8.5. 7 to 8.5. That is acceptable limit of drinking water. Okay, above the 7, that is basic in nature. If excess amount of basicity compounds are present in the water, it leads to the, what is that? Intestinal diseases. Okay, similarly for the acid, if excess amount of toxic pollutants are present in the water, it will be, what is that? strong. So, very strong. Can you able to take example for strong acid?
hydrochloric acid,
Weak acid.
vinegar,
Acetic acid. How we give the justification for strong acid and weak acid? Strong acid.
reaction.
Reaction என்ன very good. வா முதல் பாயிண்ட் வந்து
HCl இருக்கும்போது ரியாக்ஷன் ஹெவியாக இருக்கும். மீன்வேல் அசிட்டிக் ஆசிட்
லோவா இருக்கும். அப்படி கிடையாது. இப்போ வந்து H+ லிபரேஷன் ஈஸியா இருக்கா? ஈஸியா H+ இருக்கா? That is the strong acid. H+ லிபரேஷன் is very tough. That is called weak acid. Kohlrasch described that. Kohlrasch காரணம் படிச்சிருக்கீங்களா? Kohlrasch அதுதான் describe பண்ணிருக்காங்க. H+ ஈஸியா லிபரேட் ஆனா that acid is called strong acid. H+ liberated, what is that? Liberated struggling, that is called weak acid. Acetic acid taking H. எங்க இருக்கு H? CH3 COOH. அப்ப நம்ம மேப்ல பார்ப்போம். அப்ப அந்த H வந்து எதோட கம்பைன் ஆயிருக்கு? ஆக்ஸிஜனோட. ஆக்ஸிஜன் is the high electronegative bond, highest negative compound. Opposite poles are attracted to each other. அப்ப என்ன செய்யும்? அந்த high negativity hydrogen poles connection. Pole itself. அவ்வளோ ஈஸியாக ரிமூவ் பண்ணாது. அதனால தான் அசிட்டிக் ஆசிட் எது ஹைட்ரஜனை ரிமூவ் பண்ணுறது கஷ்டம். கொஞ்சம் அதோட கான்சன்ட்ரேஷன் கம்மியாக தான் ரிலேட் பண்ணும். இதே HCl என்ன செய்யும்? அங்கே என்ன பாண்ட்? அயானிக் பாண்ட். ஈஸியாக H+ லிபரேட் ஆகிடும். அப்போ என்ன ஆகும்? ஆட்டோமேட்டிக்காக H+ஓட கான்சன்ட்ரேஷன் அதிகமாகும். அதனால HCl H+ பண்ணலாம். லிபரேட்டிங் வெரி frequently. That means the concentration of hydrogen is very high. Liberating high concentration H+. Therefore, it is called strong acid. Acetic acid liberating H+ and concentration low. Therefore, it is called weak acid. That's it. Make finish properly. See, next one. Hardness. Before we see the hardness, we see about alkalinity. Next one, HCO3 minus, that is called high carbonate alkalinity. So totally there are 3 different alkalinity of the sample. What is sample? This is the strong alkalinity sample. This is both are the weak alkalinity sample. For this we have used phenolphthalein as the indicator. For both of these we use methyl orange as the indicator. Phenolphthalein act பண்ண அடுத்த செகண்ட் என்ன செய்யும்? இந்த மாதிரி பயங்கர ஸ்ட்ராங்கா என்ன செய்யும்? கலர் ப்ரொடியூஸ் ஆகும். That is purple in color. Immediately the water is turned into the, when we added phenolphthalein to the alkaline water sample, immediately the water is turned into the purple in color. Okay, so that is the magic of chemistry. Okay, so that water sample you have titrated against HCl. So at the particular point the purple color is completely disappeared. You have been noted that. That means what is meaning for that? All the OH minus ions are completely reacted with HCl. There is no further OH minus ions are present in the water. That is the end point. You have been noted that. Then don't throw this water. Water don't fill the unit also. Unit is fill பண்ணக்கூடாது. Again we have added to the orange. இதற்கு என்ன கண்டுபிடிச்சோம்? OH கண்டுபிடிச்சாச்சு. பத்திர இப்போ என்ன இருக்கு? கார்பனேட் இருக்கலாம், பைகார்பனேட் இருக்கலாம். So அதே வாட்டர் சாம்பிள்ல we have added to the orange. Immediately turn into yellow color. Add yellow color. Okay. So titrated against again with HCl. Unit is fill பண்ணக்கூடாது. Titrated against HCl. So immediately turn into reddish orange color. Reddish orange color. Okay, that is one of the experiments for determination of alkalinity water. Okay, so alkalinity means by basic in nature, there are three main types of alkalinity: hydroxyl alkalinity, carbonate and bicarbonate alkalinity. Hydroxyl alkalinity is the strong alkalinity, bicarbonate and carbonate alkalinity is the weak alkalinity. Hydroxyl alkalinity is indicated for hydroxyl alkalinity. Ethyl alkalinity is indicated for weak alkalinity.